The speaker of the day, Dr. Gangadhar Ramtekar, and all the professionals. About 54 participants have already logged in, and some of them are also on Facebook Live. Some of them who are very convenient on that. So today we have a very good topic, which is dear to all of us and which we deal on a day-to-day basis. Concrete for good construction, and we have an expert speaker on the topic who is having a combination of both academic as well as consulting experience, and I am sure that we will have number of takeaways. Now, just before we go into this thing, let me just take a brief moment to introduce about the organization. Although all of you know about the Ramco Cements Limited, but just a few words on the initiatives that we have been taking in the recent past. One thing, yes, to take this initiative of spreading the good construction practices amongst construction professionals, even during the pandemic, we have been conducting about more than 100 webinars, as all of you know, and all the webinars are also on the Facebook Live as well as on YouTube. So our basic objective is that, especially the budding civil engineers, the students who are going to enter into the civil engineering arena will also get different perspectives from different speakers. That is very important, and I am sure that the students can take best use of this particular initiative that we are having. Since the speakers are all from academics, consulting, so you get a blend of both theoretical as well as practical aspects. So that is one thing that we have been doing. Ramco Cements, as all of you know, entered the Indian cement industry in the year 1960s, and since then we have been manufacturing various types of cement. And in the recent past, as all of you know, we have about 12 brands of cement, which is there. That is, the 12 brands of cement have been customized. You know how it has been customized in the sense, we have the Portland Pozzolana cement, we have the Portland slag cement, we have the ordinary Portland cement, we have the cement for precast applications, and we have the sulfate resistant cement. Now, within Portland Pozzolana cement, there was this requirement that why not have a cement with a higher compressive strength as well, even within PPC. So that is why you will find that in Ramco cement, you will find Ramco Supercrete cement, Ramco Super Grade cement, Ramco Super Fine, and Karthik Super Plus, which are the Portland Pozzolana cement. Now, the basic speciality of Ramco Supercrete cement is that we have been able to make a cement which is having high compressive strength and at the same time have a low heat of hydration. So we have been able to customize the cement for construction work for those professionals who wanted a high compressive strength even in PPC as well, because that requirement we have been able to address. Within ordinary Portland cement, as all of you know, ordinary Portland cement 4353 grade especially is being used by RMC units because they have the facility of blending this fly ash material or slag at the RMC unit itself. So to cater to that need, what we have done is that we have customized OPC 53, 43, 53 infra and 43 infra. Now the basic idea of having infra is that many of them had this requirement of having a longer slump retention time. Some of the projects, say for example in Bangalore, they transport for more than 2 hours. So slump retention happened to be very critical in concrete. Then we had this specific segment called precast segment, where they wanted a cement with a high rate of strength, quick removal of formwork, higher number of, say for example, blocks per bag, and all those requirements, for which we have brought Ramco Super Fast, which is customized for all the precast applications. So that is the thing that we have been doing, and we have been able to do all this because of our close coordination as well as the initiatives that our research center, the Ramco Research Development Center at Chennai, which is a separate unit, which is doing a lot of work on the area of blending materials as well as on the area of concrete mix design, because there are so many admixtures that is available in the market. And one of the major challenges is that we need to find out whether the cement is compatible with a particular admixture or not. So we do those works at Ramco Research and Development Center. So many of our works are basically centered on the requirements of the customer. What does the customer, what kind of concrete he uses, what does the challenges he faces. To solve those problems, we have the Research and Development Center, where we do number of trials and number of studies. So that is the initiatives that we have been taking at our research center. So one of the recent initiatives that we have taken is that we have been always telling construction professionals to define the grade of concrete, what grade of concrete you need, what is the workability you need, what kind of durability is required. Say, for example, we have the durability measuring instrument also at our research center, like the RCPT test, as well as the water permeability, DIM water permeability test, which helps us to evaluate the durability of concrete. So if you want to evaluate the durability of concrete, it is possible nowadays. So concrete technology has advanced to such an extent that we can do any kind of test. So that is what we have been doing. Now, as far as today's speaker is concerned, let me just take the privilege of introducing him to the audience. So today we have a speaker who has made a lot of initiatives in the area of academics as well as this thing. So he is presently the professor and dean planning and development and head of the department civil engineering at NIT Raipur. He has completed BE Civil Engineering. He is a gold medalist and ME Structural Engineering and a doctorate in Structural Engineering from IIT Mumbai. His area of interest includes structural engineering, mechanics of solid, mechanics of composite materials, finite element modeling, earthquake engineering. He has 29 years of teaching experience and he has also worked as scientific officer at Nuclear Power Corporation of India. His research papers have been in numerous international journals. His research on development of a two-field mixed finite element model using single field variation principle for the analysis of delamination of fiber reinforced polymer composite laminate has been published in a book titled Damage and Fracture Mechanics in a chapter on mixed finite element for cracked interface. So he was awarded a university gold medal for securing first position in BE Civil Engineering, and he was nominated for Marcus Who's Who for 2011 edition of Who's Who in the World. He has also undertaken numerous consultancy projects. One of the remarkable was structural design and supervision of 82-meter high monument Jet Khumb at Girodipur Dham in district Raipur in Chhattisgarh state, which is one of the tallest monument in India. He is a lifetime member of all leading professional societies in India. So he has selected the most relevant topic, which is of practical importance for all of us. So let me once again welcome Dr. Gangadhar sir, and over to you, sir, for starting off your presentation. And thanks for having spared your time to interact with us. Over to you, sir. Thank you so much. Gangadhar sir, that is your mic is on mute, I think. Your mic is on mute. Yeah, please unmute the mic. Yeah. Yes, now, yeah.
Thank you very much, sir, for giving this opportunity. Let me make it clear that this particular presentation is for the field civil engineers and architects, and hence some practical aspects have been covered here rather than the latest research in the field of concrete. It will take around 70 minutes, I hope, and I am going with this that concrete for good construction. Basically, this is the aim of this particular presentation with the fundamental issues on that. So, just as we all know, what is concrete? Concrete is a composite material that consists of binding medium, cement, embedded with fine aggregate, sand, and coarse aggregate. This is simple definition of concrete, though there are nowadays many admixtures have been added to make it more relevant, more durable, and more strength-wise. The cement and water forms a paste that hardens and bonds the coarse and fine aggregate together. Coarse aggregates and fine aggregate, on the other hand, basically they are the inert fillers possessing good strength and durability. These are important features of coarse and fine aggregate. Concrete is often looked upon as a man-made rock, means the strength of that rock and shape and size of our willingness. That is the combination of the two is concrete. Actually, so concrete is often looked upon as man-made rock. And because of all this simplicity of making the concrete, concrete is by far the most widely used building material worldwide, and it is next to water. And the primary reasons for its huge consumptions are it possesses excellent resistance to water. Means a good waterproof structure can be constructed using concrete. Its ability to be plastic initially and solidify after few hours is another good property. Means whatever shape we like, we can cast that and make a stone out of that. That is what the specialty of concrete. And most importantly, it is readily and economically available at site, because in concrete it is only the cement that is a factory manufactured, and apart from this new chemicals that are being added, but apart from this cement, the coarse aggregate, fine aggregate, and water are the locally available material, and hence it is economically at site. The main advantage, if I look upon, so first one is its mechanical property. And what we look as a structural engineering point of view is high strength. So particularly concrete gives us high compressive strength, but it is not only the high compressive strength that is important. At the same time, we require high modulus of elasticity as well, because we don't want high deformation. We want with a small deformation, we can achieve this high compressive strength of the material, so that it can be used for building purposes without losing the serviceability aspect. So this particular thing basically is being given by this, provided by this concrete. So this is the first property that actually make it important for building as a building material. The second is durability. It has very good weathering resistance, but with a question mark. The question mark is not on the concrete. The question mark is on the way we are casting and way we are doing concreting work. Whether we are compacting it, whether we are curing it or not, or whether proper cover to the reinforcement is given or not. These are the issues attached with durability rather than concrete itself. But what happens is concrete defamed because of its this inability of the execution. That is what I feel. Then it has good moldability, adaptability, means wherever we want we can use it, even in the deep sea area also concreting can be done, and at many even in freezing areas also concreting can be done. Its adaptability is good, moldability is good, fire resistance is good, general availability means almost everywhere we get cement plants available, and the basic building materials like coarse aggregate, fine aggregates are available everywhere. It is quite affordable in that sense, and it is an engineered material. We must say it is an engineered material. To some material which is locally, the 60-70% is the local available material, and factory made material is only cement in concrete. That too, it is a reliable material. Means we can assure of its strength if properly it is made. That is how are the basic advantages and specialty of this concrete as a building material. So in that sense, it is most important to note that good or bad concrete is made with the same material. This particular point we must have in our mind, that good and bad concrete is made with the same amount of material. It is only a matter of our involvement that next. So if we talk about the basic components, it is the cement, aggregate, that is fine and coarse aggregate, water and admixture, that forms the basic ingredients of concrete. The biggest question for today's presentation is that how to make good concrete. And if in this way we go, this statement I hope every engineer and architect will agree with, that a good concrete can be made by the positive efforts of an engineer or architect. If we agree with this statement, then we must also agree with this statement as well. A bad concrete can be made by ignorance of the same engineer or architect. So here the positive effect can make a good concrete, as well as the ignorance of the same engineer will make concrete. So it is not the concrete that is good or bad, it is our human effort that may be positive or ignored. So in that way, meaning that all the responsibility basically lies on the heads of site engineer. So we must remember that concrete can do wonders if properly made. Means there are wonderful structures worldwide, which reflects the gigantic test, reflects the good quality of concrete. But at the same time, concrete can do blunders also if not made properly. And we are seeing many blunders associated with a concrete structure system. And that is all depends upon what effort, what way of the effort we have put in. So now coming to this, that necessary steps for making good concrete. Am I audible? If anyone can. Hello.
Yes, sir, you're audible, but
Yes.
you're
Video we have muted to save on the.
Okay, sir. Okay. No.
Dr. Gangadhar sir, the video is muted to save on the bandwidth, sir. Please continue. Thank you.
Yes, sir. Yes, sir. Okay. Okay. So now we are talking about the necessary steps for making good concrete. Because here from we are starting how to make good concrete. So the first step I found is the need of brushing up of the knowledge by a field engineer and architect. This is very important because at many places I have gone in, once the student pass out from the institutes, they go into the field, they leave away their books and course mostly. I am not talking that all, but somewhere I found that they leave away this book somewhere in the junk, yeah, and go with the completing work as whatever knowledge they have or whatever the masons or somebody are saying. So it is very important to have something like a book. So my point is that kindly have a hard copy or soft copy of the relevant IS codes and book on concrete technology. It may not be for daily reading purposes, but for referring sometimes whenever required. So whenever we find some problem, some issue in concreting, just come back to the home in the night time, just brush out all those things, what happened, and is it given somewhere in the literature or not? It is given. It is given in a more justified way or logical way. It is elaborated in the books. That will make our knowledge more sound and sound for the field engineer. That is my first request, and this is the first step basically for making good concrete. So, and one important thing is engineers and architects, on the other hand, should educate their fellow persons involved in the process of concrete making, because the actual person that is involved is that person associated with a mixer or the person associated of the concrete and compacting of the concrete like this. Actually, sometimes they are so means because of their experience and the person engineer is say less age wise is less, they are not listening to him. But it is our job of the field engineer and architect to make them also understand the relevant importance of each and every process that is carried out for making a good concrete. So this is the first step. Now coming to the second step is procurement of material. It is very important. We generally whatever is available in the local area, coarse aggregate, fine aggregate, that we go with. And sometimes with cement, certain priorities are fixed, but otherwise it is also taken in that way. So procurement of material I would like to talk about is cement. Cement is the first material. So cement is a factory produced material, building material used as binding material for concrete because of its property of having good adhesion and with the aggregate. Means it binds properly the stone pieces like coarse aggregate and fine aggregate with strength in presence of water. This is what cement is actually. And a variety of cements are available in the market, but the most commonly used are nowadays OPC is not that highly used. It is the PPC and PSC cement because of its invariable advantages as well from durability point of view. They are mostly being used. It is on special demand now. OPC is manufactured in the factory. There are many other cements, but for a general purpose, these three categories of cements are being used. So about cements, since cements are manufactured under good quality control in sophisticated factories, one can rely on its quality because it goes through various quality checks in the factories. However, for the field, it is definitely necessary that IS code provides various test procedures for quality checks of cement and which can be done at the site laboratory, and that is mostly done in the field. Second important material for concrete making is coarse and fine aggregate. Now, if we look upon a concrete mixture of cement water paste mixed with inert coarse and fine aggregate with very small amount of admixtures if required. Nowadays, mostly it is used. Thus, by volume, if we look upon the concrete, approximately it consists of 7 to 15% of cement as per the grades of concrete, and 14 to 21% of the is water, but rest 40 to 45% is associated with coarse aggregate, and around 20 to 25% is that associated with fine aggregate. And in that way, we can say about 60 to 70% of the total concrete volume is associated with coarse and fine aggregate. And that way, a large chunk is associated with this coarse and fine aggregate. And hence, care must be taken while its procurement of the coarse and fine aggregate. It is worth to say that aggregate forms a major part of the concrete. Now, why coarse and fine aggregates are basically used are they are the cheap filler. Cheap cost wise, they are the cheap filler, means if I say unit volume cost of coarse or fine aggregate as compared to that unit volume cost of cement, it is much cheaper, and it is strength wise it is good. It is very hard material, and importantly, it is not that the cheap and hard material, but it provides volume stability. Means a pure cement tube if I make and a concrete tube I make, volume stability will be more with that concrete rather than a pure cement tube. So it gives a volume stability to our structural system. It reduces volume changes, shrinkage is less, and thus it provides abrasion resistance as well. So these are the important features of using coarse and fine aggregates. Now, there are variety of coarse aggregates available in the field, in the areas. This rounded kind of coarse aggregates are available, and they are basically from river we get. Since they are rounded in shape, the surface area is less. Hence, with less cement paste, we can have a better workable concrete with us. Moreover, the possibility under loading of its breaking of these stone pieces under loading is very less. It is not almost not there. Hence, they are good for making concrete. This kind of a material is good for making concrete. But these are not readily available everywhere. What is available is these two types. One is the crushed stone, which is in cubical shape, and crushed stone in elongated and flaky shape. So a combination of all these we are getting. So we must assess about the percentage, how much percentage is of this bed material as such, elongated and flaky material. Because if it is a cubical material like this, the chances under loading of its breaking is very minimal. It is not almost not there. But if we are having a elongated or flaky material in our concrete, under loading, the first thing that it will do is it will be broken into pieces because of compressive load, and because of elongated and flaky shape, it will easily be crushed under loading. And once it is crushed, cracks are formed, and once cracks are formed under further loading, there will be stress concentration and propagation of cracks will take place, and early failure of concrete system will be there. Hence, this material should not be used. So this will help us in, say, if I am having a our quarry or two crushing stone plants, and from one I am getting higher percentage of this as compared to this percent, then I will choose this particular quarry or this particular crushing plant to take coarse aggregate from. That is what is the importance of having this. So what basically we require as a coarse aggregate is a non-dusty, non-flaky, non-elongated, non-deleterious, well-graded and good crushing and impact resistance, good freezing and thawing resistance, good soundness are the required properties of aggregate for concrete. Now here I would like to point out this non-dusty. So most of the time the construction site is associated with a kacha road, means it is a either mulu or something. and many of the trucks are passing there, and dust is placing over the coarse aggregate available there. If we are using this coarse aggregate without washing it, this layer of dust will be there in between the coarse aggregate and that cement paste, and this layer is very weak, and as soon it will be subjected to loading, there will be initiation of cracks and furtherance of cracks leading to failure of concrete. Hence, if coarse aggregate is dusty, we must ensure its washing with water and drying it before using it for concrete making, because this makes a lot of difference strength. If we have washed a dusty coarse aggregate particle and then use, and without washing we use, there is a, I can say, 50% strength remains with dusty, even less than that I can assure of. Similarly, about the fine aggregate, what fine aggregate we require is that non-silty fine aggregate as such. And how to find out a sand is having a larger percentage of silt or not is just by pouring our hand inside. And if we get our hand with dust, filled up with dust, then it has a large amount of dusty or silt particles in it, which is not good for concrete making, because it forms lumps and that proper, so this cement binding is not taking place. So what should we do? What is required is a non-silty, non-flaky, non-mica, non-flaky, non-deleterious, well-graded fine aggregate is good for concrete making. Now, if fine aggregate is dusty, we must ensure its washing with water and drying before using it. This is also an important task before us for using coarse aggregate in the field. Bulking curves, because there is a phenomena of bulking that takes place when it is a moist sand, then bulking curve of sand should be prepared and should be used for evaluating the volume of sand for concrete making. So this is about fine aggregate. Now the third material that comes is the water. So a popular statement about water is that water fit for drinking is fit for concrete making. But in these days, getting water fit for drinking and for exclusively for drinking purpose is a difficult task. What about to talk to concrete making? So it is a difficult task to get water somewhere. It's many locations. It is very difficult task. So about the water, it is said that a water with pH value between 6 to 8 and that free from organic impurities is good for making concrete. These two statements are correct, but how to find a water is good or not, which is not a drinkable water, then that is the question. Then I came across a book written by Dr. Remedio, who was a person associated with concrete. He has written a book, and there I found that the best way to judge the suitability of water for concrete making is that make concrete cubes with the available water its side. Means if somewhere we are having a pond to get water from or a river to get water from, then with the available water its side, and also make a companion cube with the same ratio proportion of cement, coarse aggregate, fine aggregate, with the same ratio companion cube with distilled water, and see the 7 and 28 days compressive strength. If the strength of the concrete made with water available at site is equal to or greater than 90% of the concrete cube is made with distilled water, then the water available at site may be accepted. This is a field test that can be performed everywhere, that we will take 20-25 liters of distilled water with us and 20 liters of that pond water, and we can make two separate set of cubes with same ratio, and we can test after 7 and 28 days and can assess if the strength is that of 90% of that cube made with distilled water. We can take that water into consideration for making the concrete. This is how we can go for field test for assessing the quality of water for concrete making. Then the fourth, the material, it is in the same step we are. Step 2 this procurement of material, admixtures and construction chemicals. There is large number of admixtures and construction chemicals these days are coming up. They are making our concrete very good, and by reducing the water cement ratio by many ways, they are doing good job. So admixtures and construction chemicals improve or modify some or several properties of concrete. They also compensate for some deficiency present in the concrete. Use of admixtures or superplasticizer reduces the water demand of the mix by deflocculation the cement particle. Due to deflocculation, the cement particles are evenly distributed, hence the quality of concrete improves. So superplasticizer, using a superplasticizer is good in that way. There are other retarders also are coming up, because if, these days are ready mix concrete. Concrete is mixed at one places, and it may take 2 hours, 3 hours also to go to the site. So in that time, it should not have fall into initial setting time, and for that reason, many retarders are also being used as construction chemicals. So advantages of water reducing admixtures are: it increases the consistency. Consistency is very important phenomena. I will talk about it later, but consistency of concrete is very important. Even distribution of all this paste and coarse aggregate and fine aggregate is that we mean by consistency. Achieve higher compressive strength, and cement saving is also there in case if we are using these construction chemicals. So this is about the step 2, that is procurement of material. Now we are coming to the step 3 about the concrete mixing. Now when we talk about concrete mixing, as per the concrete mix design, the weigh batching of cement, fine aggregate and coarse aggregate done. Whatever in our laboratory also, the mix design that we give is based on weigh batching, and because weigh batching is reliable. But in the field, sometimes the people go with volume batching, like 1:2:4 or 1:1.5:3. Like this, they are saying. Here also, we are seeing that most of the even government people are talking in that term. So I would like to say that weigh batching is preferred for concrete mix. Suitable adjustment for quantity of water as per the moisture content of aggregates should be done before mixing. This is another issue. If it is not possible to have weigh batching in the field, now it is addressing that problem of the field, that if we do not have, it is not possible to have weigh batching in the field due to any reason, then volume batching of the concrete with proper conversion of this ratio water to cement to fine aggregate to coarse aggregate. This conversion, which is given in weigh batching weight form, should be converted into volume form on the basis of their bulk unit weight. It should be done. So once it is done, then we can say that we are actually doing the weigh batching, but volume wise we are doing that. It can be said like. The important thing about concrete making is the water cement ratio. All the books talk about the importance of water cement ratio. There is Abraham's law since very beginning, that more is the water, less is the strength. There is logic very clear why more is the water and less is the strength. Logic is very clear that the amount of water required for chemical reaction definitely required. The amount of water for filling up the gel pores definitely required. But other than that, water remains as water, and after certain time of its casting and its setting up, the water gets evaporated and leaving voids in concrete. Voids in concrete is pre-assigned cracks in the concrete. And when pre-assigned concrete cracks are there, it will easily be subjected to stress concentration, and then propagation of cracks will be there, and failure will take place. But in the field, I found, means not, I am not talking about the sophisticated computerized batching plants or RMC plants. I am not talking about that. I am talking a locally available mixture with me, and a person is mixing concrete and using for slab or concrete column making, like that in a building. So there, water cement ratio is the most important parameter for strength. Hence, this I find in all such cases the amount of water person is using in a unit volume of concrete, he is not knowing, and nobody is bothering as such. Even a engineer standing there is also not bothering about what is that container a person is using for adding the water in that concrete mixer. It is just a servo or some oil can one person has got in the roadside, and the person are using that without having what volume of water it is per drop, how much volume of water it is hitting to the concrete. Nobody knows. It is like that. This one figure is a very scientific figure in that sense. A container for water pouring in the concrete mixer. This is a container with a slot here, and water below this slot is representing a capacity, that is, say if it is 5 liter capacity, 5 liter here means water below this is actually representing 5 liter. Now as soon from a drum we are taking this water using this container, all the other water will go away from this slot, and the water remain in this will be a 5 liter water. It is a measured water, and that way I can always say what is the water cement ratio I am using. Please, one should take care of this small thing in the field for making good concrete, because otherwise what volume of water we are using, if it is not known, we are not assured of the strength of concrete or good concrete. Important thing is about this handle as well. I would urge that a rubber or some foam should be placed here, so that the person using this should be easily able to use it without any damage or difficulty in his fingers. So that arrangement should be made for, because keeping into the importance of this water cement ratio in the strength of concrete, it should be done this way. Now, once concrete is mixed and taken mixer, we see whether the concrete is cohesive or not. Cohesive concrete is very similar to, like we are making chapatis and there is wheat flour and we are adding water and mixing it for making chapatis. Now, if it is not properly mixed, then chapati is hard, and if it is properly mixed, chapati will be very soft and tasty. That is in the similar way we want a concrete to be cohesive. Cohesive means everywhere it is the same proportion of coarse aggregate, fine aggregate, cement paste is there. That should be there. Then this is he is Mr. Remedio, who was a concrete engineer. Recently, some 3-4 years back, he died. So he has given certain ways to judge about the cohesion of concrete. And what he says is, it is the ball or laddu test he talks about. Take green concrete from the mixture or concrete heap about the size of a cricket ball. Cricket ball is something of the size of 3 inches or 75 millimeter. So it says that take a green concrete from the mixture or concrete heap about the size of cricket ball. The concrete should be formed and placed into about 75 millimeter diameter ball, 3 inches, between both palms in the of the hands. If the fine aggregate and coarse aggregate are well graded and mixed in an efficient manner, mixer, the concrete will be cohesive, easily formed into a ball with cement mortar fully covering the coarse aggregate particle. It is like this, as shown in this figure. Means this is something, coarse aggregate are all inside and cement, this mortar fully covering the coarse aggregate. The coarse aggregate particles should not be visible. This is what about the cohesion. Now there are certain cohesion tests he has recommended. He has talked about a concrete. What concrete we should say? We will say as nil cohesion. It says if concrete ball or that laddu does not form and excess coarse aggregate particles are seen as seen in this figure, it means that the concrete is under sanded. Less amount of sand is there, or the fine aggregate is not fine enough for, and the concrete is considered to have nil cohesion. This is not a good concrete. Hence, the concrete mix should be rejected. Means this is a trial before actual execution of construction work, this trial should be done in the field. That is what it means. Hence, the concrete mix should be rejected and fine aggregate should be increased. Coarse aggregate should be reduced according to get cohesive concrete mix. This is what it says about the laddu test. To a concrete, we will say poor cohesion is that if concrete forms into a ball, laddu, but some coarse aggregate particles are visible. Some coarse aggregate particles are visible on the concrete ball surface. Then the concrete has poor cohesion. If this ball is dropped onto a flat surface from a height of about 15 centimeter, 150 millimeter, 6 inches height. So if these are dropped from 6 inches height on a tabletop, and if it breaks, it means that the concrete is not cohesive enough and therefore is still slightly undersanded. It is undersanded or less fine aggregate. Hence, the concrete mix should be rejected and fine aggregate should be increased and coarse aggregate should be reduced accordingly to get cohesive concrete mix. So, this is second for poor cohesion it is talking about. This is the figure. Third is about good cohesion. To what we will say as good cohesion. If the concrete ball forms and no coarse aggregate particles are visible like this and they are covered with cement mortar, it means that the concrete has good cohesion. And if the concrete ball when dropped onto a flat surface from a height of 150 millimeter and does not break when it lands, it means that the concrete has good cohesion. This is what we have classified it: nil cohesion, poor cohesion, and good cohesion. There is one thing about over cohesion also that I have not mentioned because of the paucity of time. One can see that. Now about the concrete mixing, we must look at about the function of that cement water paste or cement grout. What is the function? And understanding this function will make a good concrete. If we are not understanding, we will not take care of that. So the question that arises here is what we should see in green concrete. This is important. This is particularly important for new field engineers who are associated with the job. Whenever there is concreting, just you go and see what is happening, and he stands up there. But sometimes he doesn't know what to look at, means whether to say this particular concrete is good concrete or bad concrete, what to say. So he must know about the segregation of the concrete, what takes place, and he must basically know what is the purpose of this cement grout and what we should see in this green concrete. Here I have a two concepts to talk about, and this is just a concept. Don't take it as that it is the field practice. I am talking about a concept of concrete in terms of its use of this cement grout. I have two situations. One concept I am taking for making a concrete, green concrete. What I am doing is I am making a heap of coarse aggregate, and naturally that heap of coarse aggregate will have certain voids in it. Inside, outside, everywhere the voids will be there. Then I take sand or fine aggregate with me, and some meticulously I drop that sand, and I say conceptually that all the voids that is created by coarse aggregate are filled up with this fine aggregate. Now the coarse aggregate voids are filled up with this fine aggregate, but there will be further voids available between this after pouring up this fine aggregate as well. Now what I am saying, whether it is feasible or not is not a question. It is a concept that now I am saying that I am having a cement water liquid with me, cement water paste I am having with me, and somehow I am pouring all those cement water paste at the locations of all these voids left. All this, almost all the voids now left has been filled up with the cement grout there. This is one way of understanding a concrete. But in this one way, now the second way. Now just talk about the second way. Second way of concrete I am visualizing a concrete in such a way that I have a container with me, and in that container I am having cement grout or cement water mixed is there in that container. And now I am taking some of the coarse aggregate, I pour it inside. That coarse aggregate is poured inside, and with a strainer, एक छन्नी के द्वारा, with a strainer I take away that coarse aggregate and make a heap of that coarse aggregate. Now naturally with that, in that heap of coarse aggregate also there will be whites available. So now what I do is I take another in the container, I take this fine aggregate with me. I pour that into the container with cement water mix. I pour it on that, and with a strainer I lift that fine aggregate, and meticulously I am putting all the whites that is created by coarse aggregate. I am filling up with the fine aggregate. Means all these pores are filled up with the fine aggregate. Now still whatever are the whites available are being filled up by the cement water paste or grout I am filling that. This is the second concept of concrete. The first concept and second concept. Naturally, all of you may be knowing that the second concept is more relevant and more appealing. Why the first concept is not good is that when I have a heap of coarse aggregate, means there is a direct touch of coarse aggregate with each other. And when there is a direct touch of coarse aggregate, and then I have put the fine aggregate, there is direct touch of fine aggregate with the walls of the fine aggregates they are touching each other. Means there is no cement slurry available in between. Now the whites have been filled up in the case 1. It means already there is only touching coarse aggregates are, though the density may be same, but with this density we are not achieving a good concrete. Why? Because those direct touch between coarse aggregate and fine aggregate are the already incorporated flakes in the concrete. Already they are touched, they are not pasted. And when they are not pasted, they are simply touched, then there is already flake available in that concrete, and it will lead very early failure of the concrete. Whereas in the second concept, if we look at, what I did is all those coarse aggregate are first poured into a container containing cement grout. Means all the surface around that coarse aggregate has a layer of this cement grout now. Means if I am making a heap of that particular coarse aggregate, I can assure that there is no direct touch of coarse aggregate with each other. It is always a cement grout in between the coarse aggregate. And similar is the case with that fine aggregate. There is no direct touch of fine aggregate. There is a cement layer, and that is what is the purpose of a cement, that it should bind. If it is available everywhere in the walls, the boundaries of the coarse aggregate and fine aggregate, it will bind everywhere, and such a concrete will not have initial cracks in it. It is the loading, that heavy load will be required to initiation of the crack and then furtherance of the crack. Means it has a too large strength as compared to earlier concept of the concrete. This is very important to understand. Once it is understood, then we can judge what should I see.
Can I interrupt, sir?
Hello?
The slide is not moving, I believe, sir. The slide.
I am not doing. It is in the step 3 concrete mixing.
Okay, okay. Okay. So same slide only, no? What we should see in green concrete.
I will just
okay.
Now I will start it. Okay.
Okay, sir.
So
okay. We thought it would have stopped. Okay.
So now once I see this, once the mixture is the concrete is brought out of the mixture, the person engineer there should see if there is segregation of if any coarse particle or fine particle is completely washed with water and a piece of that is there or not. If it is, then it is not a good concrete. If it is not, for all the concrete, all the coarse aggregate, there is a layer of cement grout, then it is a good concrete. That is what I wanted to highlight. So in that way, I can say the cement in water forms cement grout, a viscous cohesive slurry like glue. cement grout has three purposes: binding, filling, sliding. Now, in this schematic diagram, if I consider all these as coarse aggregate or fine aggregate, they are like touching each other. But as soon I make a binding material cement grout, I visualize it like this, that all these coarse and fine aggregate are surrounded by cement grout. And then further, any further cement grout is there for making the filling of the gaps. And then further course the cement grout is making it to slide, and that is making a workable concrete. This is how is the concept of concrete in that way. So this is about the concrete mixing. Now, in concrete mixing, the term workability also comes. So we already know about that. Workability is the property that determines the ease with which freshly mixed concrete can be placed and finished without segregation. That is important. Workability is measured with slump compaction factor test. There are now many tests available. Rheological tests also have come up. Written with the field consideration that workability is measured with this slump and compaction factor. Slump is useful for medium workability concrete. However, compaction factor is preferred for low workable concrete. Water content, if we talk factor affecting the workability of concrete, water content, the higher the water content, higher will be the workability of concrete. Is a very easy to say, but for good quality concrete, water should be the last option to be used for increasing workability. Means for increasing workability, we should go for chemicals rather than by increasing the water cement ratio, by increasing the content of water for making workable. It reduces the strength. If more than the required water is added to concrete, cement quantity must also be increased according to water cement ratio. This is what a option given to us. Mixed proportion, a mix where the voids between the coarse aggregates are filled by fine aggregate and cement paste is only used for binding is very much desirable. Means not excess amount of cement paste should also be there. Surface area of all ingredients must be as low as possible for workable. Always wave weighting should be preferred over the volume weighting. Mixing of concrete by a good mixer is must. For important work, hand mixing should not be done. Nowadays, it is not done hand mixing, but somewhere we find that hand mixing also is done for poor work. There is the shape of aggregates, angular, elongated, tricky shape will make less workable. Biggest size possible, biggest size possible should be used for making a workable concrete. Surface texture, if it is rough surface texture, then less workability will be there. So far as the outside temperature is concerned, concreting should be avoided when outside temperature is more than 35 degrees. In country like India, it is very difficult to get temperature below 35 degrees in most of the time. So my suggestion is that important concreting should be done during night time. This is the only take from this sentence I can have. Then grading of aggregate, all the aggregates must follow desirable grading requirements given in IS 383. It is well known that well-graded concrete will have least voids. That is important for us. And use of admixture, they reduces the water demand by deflocculation process, and thus they are good for concrete making and good workable concrete. Now, once it is about the concrete mixing, now the fourth step that we follow is about the its placing. What should we take care of during its placing? It is the compaction of concrete that is most important. And at many places I find that yes, people are worried about this compaction. Needle vibrators are there, surface vibrators are there, but in some places where people are not giving that importance, or the associated person, I find that surface vibrator is mostly not workable, and it is there, but it is the manually we are compacting the concrete. It is not good. It makes the concrete very wide prone. The presence of void in concrete is dangerous because they are already involved cracks in the concrete. So the presence of voids in concrete is dangerous as they result in reduction in the strength of concrete. As an estimate, 1% of voids in concrete results in 5% reduction of the strength of the concrete. This is the ratio. Is 5 times we will become the loser, and in long term it is very difficult, dangerous because it affects the durability as well. So voids in concrete results in increase of permeability of concrete, thus causing ingress of moisture and CO2, which causes corrosion of concrete and reinforcement. This affects the durability here. So voids should not be there, and a proper care must be given for this good compaction. Hence, it is a point to compact the concrete using vibrator while placing the concrete. It should be taken everywhere, even for a small work. It should be kept in mind that vibrator must be there, and particularly at locations in beam column joint where there is a congestion of reinforcement and where there is most requirement from earthquake point of view as well, that we should have a wide free good compacted concrete, and it is there the most voids are available because of not doing proper compaction using the vibrator. So that care must be taken that at such location and at every location for that matter, we must have a good compacted concrete using the so care from a site engineer must take care of all these issues. That is what my I want is. The step 5 is coming about the curing of concrete. So now curing is also very, very important, and all the chemistry of curing is known to us, most of the people. Why curing is done? Because it is a chemical reaction. It takes long for long time. It requires water. Exothermic reaction is there. Water is evaporated. It requires more and more water for completion of the chemical reaction. Only with the completion of chemical reaction, then only we will get a good strengthened concrete. All these are known, but still people are not giving that importance to the sector. Here, this is a research study done by Professor Mehta in USA, and he has given this chart. And I have taken that chart from his book. And it says that if a concrete is not cured with water, and it is only for the full time, it is in entire time, it is in the air only. If it has a strength of the order of say 50 here, something of the order of 50, and a concrete which is moist for full time of say 28 days or even 20 days, 21 days, if it is under full time, the same concrete will have even more than double of the strength, and this matters. And that is this actually graph shows the importance of curing, which we are generally neglecting. Means we are giving this importance. We say contractor curing kar diya karo, but whether it has been done or not, and for full time and in proper way. If it is a column, how should it be cured? If it is a slab, how should it be cured? If it is a beam, how should it be cured? This all must be thought about, and curing must be done with importance to that. So this is the issue that concrete derives its strength by the hydration of cement particles. The quality of the product of hydration and consequently the amount of gel formed depends upon the extent of hydration. Hence, curing of concrete is of utmost importance. Better curing avoids shrinkage cracks as well. So this is the importance of covering, and this is actually the step 5. Means we have come from educating the engineers and architects to this step, 5th step of making good concrete. The final aspect about the concrete is that of durability. And durability of concrete has taken a prime stage now in our course also. In 1978 IS 456, it was not given that importance, but in the 2000 code of IS 456 and now also in other codes, durability has taken a central stage because it makes actually because of non-durable concrete is defamed, and concrete is defamed because of non-durability done by the person who has actually casted that concrete and who was the in charge of that basically. So durability is very important. It all talks about the cover to reinforcement and carbonation depth and packing density of the concrete, permeability of the concrete. Everything is there. How to increase that? If there are specific process available. If I want to increase the packing density, there are materials like silica fume, metakaolins, etc. They are there to increase the packing density. This PSC concrete cement also is good in that sense. There is a proper cover to reinforcement should be there. This is all. Durability of concrete is the ability to resist weathering action, chemical attack, abrasion, or any process of deterioration. Lack of durability results in reduction in the life of structure. और इसी कारण for this very reason we find a dilapidated concrete structure in very early time of 10 to 15 years time. Life of RCC structures are assumed to be 100 years. It is assumed to be 100 years, but actually it hardly completes 50 years. It is even not completing 50 years, 20, 30 years we see the defects on it because of the lack of durability. This also requires a lot of maintenance to keep the building in service. There is a lot of investment further required. Any treatment, this must be written, read well. Any treatment will not be as durable as good concrete. Even if we are making waterproofing of our concrete in slab, but it will not be as good concrete, as durable concrete as actual concrete is made like. Causes of inadequate durability and measures. Primarily, water, carbon dioxide, and oxygen are the most relevant to durability. Their movement in concrete depends on permeability of concrete. Hydrated cement paste has some inherent permeability which can be reduced by use of lower water cement ratio, and there are other thing also with which we can reduce this permeability. Voids in concrete can be reduced by optimum proportioning of the aggregates. That is why well-graded aggregates. Properties of aggregates vary a lot. Hence, frequent change in the mix design is required for making concrete. Because it is the batch-wise, it depends upon how coarse aggregate and fine aggregate we are getting batch-wise. Even cement also batch-wise we are getting differently. Now, coming to the concluding remarks, it is the last slide. Concluding remark is good concrete is made by keeping in view the 4 basic required properties of concrete. They are cohesion in the concrete, means while making the green concrete, whether it is cohesive or not, for which Laddu test I have talked about, workable concrete, and strength and durability of the concrete. These are the 4 important pillars of good concrete. A leak-proof, strong, and durable concrete may last over 100 years. This is not a surprise. Yes, it lasts for even for more over 100 years without maintenance and repair. Concrete can be treacherous material. It can be a treacherous building material if made without knowledge and strict supervision. That is what everywhere we see mostly. Structures made with poor concrete will leak and slowly crack. Thus, cancer of concrete starts. Ignoring these defects lead to collapse within 15 to 30 years. Accurate batching of concrete materials, right amount of water, thorough mixing, proper compaction, and sufficient curing are the important stages for the making of good concrete. Now, importantly, these 2 sentences we must see. There are many. It is a teamwork. Many persons are involved in the whole process of building making. One person's carelessness can lay down the whole job of concrete. Whereas every person, it is not one person, every person's care can make the concrete job to be proud of. So concrete always can give us a proud if properly it is made, with taking all the care that I have narrated, and there are many more such things. If it is done, concrete will give structure, will give a proud feeling. This is one such structure I have designed. I got this fortunate. I was fortunate to design this structure. That was actually said. It is a 82 feet tall, 82 meter, sorry, 250 feet tall Jaitham constructed in Chhattisgarh area, and I was the structural designer of that. And it is made with concrete, and it is very nicely made by the PWD department of Chhattisgarh, and along with the Simplex as the contractor of it. So this is all about my presentation. Thank you very much for giving me this opportunity.
Thank you, sir. Can we have some questions and answers, sir? Because few queries have come. So the first question that most of them are having is that why does after concreting, sometimes there is dampness seen on the concrete surface in sealing. What could be the reason for that?
In sealing,
Yeah, dampness, after concreting, if dampness is seen, say, for example, after 5 to 6 months on the roof concrete.
roof concrete, I don't think, but basically it is in the attached with the ground, there is capillary action that is actually observed. But
Okay.
if in the roof, I don't. But
I think
will-
probably
will
because
try
after
to-
the rainy season, no? Because after the rainy season,
that is all related with the seepage of the concrete. After
Oh.
rainy season, if you talk, that is all related with the seepage of the concrete, and that
Correct.
is way
Because-
it is not good.
yeah, it has something to do with compaction also. If the concrete is not
Yes,
compacted
definitely.
properly.
Compaction is very, very important, because if it is not done well, there is voids available and water will be able to pour. There is bleeding of concrete during its casting, that may also happen, and leading to availability of pores, and that will lead to the seepage of the thing.
Correct. Because and sometimes I think water cement ratio is also high. It can lead to problem, as you rightly explained.
Yes,
The
definitely.
importance of water
Cement ratio,
cement.
higher the water cement ratio is, there is higher amount of voids due to evaporation of water will be there. That all leading to the poor concrete.
Yeah. I think a combination of all this, because when they use this volume batching without proper conversion and high water cement ratio and poor compaction may lead to all this, I think, dampness, leakage and all that.
Yes.
Okay. Another thing is that how much cement should be added if the water is added for increasing the workability?
How much? Pardon me?
How much cement must be added if, say, for example, sometimes at site you add more water for increasing the workability? Yeah.
Yes.
So how much cement, additional cement must be added?
How much means the water cement ratio should not change. Say
Correct.
water cement ratio I have taken as 0.5, say. So
Yeah.
if I am adding more amount of water for the same 1 cubic meter of concrete, so cement should also by weight should be added that much, means twice that weight. Say 500 gram of water is added, means 1 kg of cement should be added. In that
Okay.
way, the water cement ratio will be maintained.
So I think water cement ratio is the correct benchmark. They should look at the water cement ratio,
Yes.
and according to that, the cement must be added. That is the correct.
And that is why the other way is one should use the plasticizer for making the concrete workable rather than using the water.
That nowadays people, they are more interested to waterproofing solution over concreting. Is it really required? Is one query asked by one of the professionals.
So actually, it is required when you are not making good concrete. The whole topic is about how to make good concrete. Once it is made good concrete, this thing is not required. The waterproofing is as such not required. And if it is a good and durable concrete made with care, this is not required, because any such solution is not a lasting solution. It is just for 2-3 years. Next time again you will require to do the same waterproofing if it is not,
Yes.
if it is a poor concrete.
I think that's a very good point. If good concrete is made, there is no need of any waterproofing at all. Very true.
Yeah.
See, again a question on dampness. He says the dampness is not visible immediately while ponding. It appears in the next monsoon. There were no cracks or honeycomb on concrete surface. What could be the reason for that?
But anyway, if damping is there, the reason is that there is microcracks available and water is pouring and capillary action may be taking place. Something like that is happening, though it may not be visible with naked eye.
All right. So is there any chance of condensation due to entrapped moisture inside concrete, sir?
Condensation?
Any chance of condensation due to entrapped moisture inside the concrete over a period of time?
That may be the reason. Means you are talking about this lime, presence of lime and all that.
Some condensation may happen or something because of which, after a long time this damp is seen. So that could also be one of the reason, I believe.
Yeah.
Because if it is visible immediately, we can say that there are some pores or something like that while ponding itself.
Yeah.
So it was a lot of minute details actually you had covered, which was very useful from the practical perspective. And in some area, aggregate quality is so bad, like so small and flaky, but customer still has to use due to unavailability. Is there any solution for that? Is one of the question asked by a professional.
As such, there is no solution, but if This is all depends upon what kind of availability is there, what kind of say is there from our side with the crushing plants and all that. But if it is a flaky, that is a problem, and there is no solution as such. We cannot avoid using coarse aggregate, and if it is flaky and elongated, means it is all giving that poor results as I mentioned.
Okay. Sir, what is the proportion required? One question is, what is the proportion required for M30 grade of concrete for pre-stressing?
No, it is not for pre-stressing or RCC. M30 is M30 basically, and M30 is 30 megapascal should be its characteristic compressive strength. And that actually we do in our, it depends upon coarse aggregate quality and the sieve sizes of the coarse aggregate, fine aggregate, and all that, and cement also. Mostly we get for M30 grade of concrete with PPC around 400 kg per cubic meter of concrete. 400 kg of cement is required.
Okay.
Around.
So that, I think that is a very good, fairly, if 400 kg per cubic meter is there, I think probably they can easily get M30 grade of concrete.
Yeah.
Sir, does aggregate cement ratio have any role in dampness? Is another question that is being asked.
Aggregate cement ratio.
Yeah.
Aggregate cement ratio. Basically, everything depends upon whether your concrete is porous or not. So, if
Okay.
you are making a non-porous concrete, I will further see whether this kind of effect is there or not. I will let that person if he asks question. But right now, I can say it is all about the making good concrete.
All right. Sir, if we add water, keeping the water cement ratio constant, I do not know how water cement ratio will be constant. If we keep adding water cement ratio will not be constant, no? But the question says, if we add water, keeping the water cement ratio constant, is there any possibility that it would become less cohesive as the fine aggregate or sand is not increased?
Means by increasing the cement he is making. This all should be looked at in the field. One of the limited option is given that if at all you don't have any plasticizer and you are adding more water for workability, then you should add water accordingly the cement also, so that the ratio should not change, because the strength of concrete is largely depending upon the water cement ratio. With that reason, but it is not open ended. It is any amount of water like this. It is not like that.
And if we use only rounded coarse aggregate in concrete, will it impact the flexural strength of concrete?
No, it will not.
So rounded aggregate will not impact.
Basically, his question seems to be from the viewpoint of frictional resistance between a rough aggregate and having no friction between the rounded. That is probably the question, and that is not affecting the concrete. This kind of a thing is affecting the road material. As a road material, when we are using coarse aggregate and all that, not the concrete. Concrete has a different way.
Sir, any other durability parameter test other than RCPT or water permeability test that can be performed on concrete for durability?
For durability, there is this RCPT, as you said, and permeability test and carbonation test is also there.
Okay.
It talks about the depth of carbonation. This possibility, if reinforcement is falling in that depth, it will be rusted in due course of time. So, if carbonation depth is say 1 centimeter and my reinforcement is at 4 centimeter away from the outer surface, then chances of it getting rusted is not there. Like that.
So thank you so much, sir, for that clarifying the questions as well as for that good presentation on concrete, which I am sure would have been of use for all the budding civil engineers as well as field engineers. So on behalf of Ramco Cements, I again thank you for having spared your valuable time. And I thank all the professionals also who have joined us. And I'm sure that this presentation, which would be available, would be of use, and it can be used any time for having some kind of guidance or tips to make a good quality concrete, because you are given a lot of practical tests like the ball test and using of distilled water as a comparison to the available water. I'm sure that this practical test would be of use to all the professionals. So thank you so much, sir, for your time.
Thank you very much to all the participants for listening patiently, and
thank you,
to the Ramco Cement for giving me this opportunity. Thank you very much.
Thank you, sir. So I sign off from today's webinar,
Yes.
And please stay safe and wishing you all the best. Thank you so much.